Hello students, Jai Swaminarayan. This is Professor Urvish Mewada, Head of Electrical Engineering Branch, Sri Swaminarayan Institute of Technology, BAT, Gandhinagar. I am the subject matter of the subject Power System 2, which is in the GTU, and the subject code is 3150911. Uh, this is the fifth SEM electrical subject offers from the GTU. Today we study about the chapter number 7, which is Corona. Now we start with the introduction of the Corona. Now what do you mean by Corona and how it forms? So uh, whenever the spacing between two conductors means here we are talking about the conductors which are placed on the transmission line. So as you already seen the transmission means transmission tower. So in transmission tower you can see you see the all three faces, they are separated to each other having equal spacing. Now here the point which is showing that spacing between two conductors means the placement of that two conductors is less than their diameter. If the diameter of the conductor is suppose x and the spacing between two conductor is less than x, then and if the applied potential between them is gradually increase, means if you put spacing like this, means the spacing between two conductor is less than the diameter of the conductor, then applied potential between them gradually increased, and due to this violet glow occurs around the conductor along with the hissing sound uh, at a certain value of potential. Now this whole this this whole phenomena of producing the violet glow surrounded to the conductor is known as the corona. Now corona generally appear in the moistured atmosphere, means that atmosphere supports the corona, and the these are the causes of corona in the transmission system. So first is hissing noise, and then we can see the faint violet glow surrounded to the conductor, and production of ozone gas, means whenever the corona forms surrounded to the conductor, then ozone gas forms surrounding to the overhead lines. These are the effects of corona when it is generates and when it is formed. Now whenever the corona appears, this appearance of the corona is depending upon the surface of the conductor, means the conductors which we use in the overhead lines. So if the cable is smooth, means surface of the conductor is smooth, then corona which appears surrounded to that conductor is uniform, means there is no zigzag in the periphery of the circle of the corona. And if the cable is rough, then corona round glows brighter, means in previous case, means in the cable is smooth, then corona appear but it is not brighter as compared to the rough conductor surface. So again it indicates that if the conductor surface is rough, then corona glow is we can say the glow is very dark. You can see easily see the corona, means appearance of the corona is very brighter. So this is the introduction of corona. Means corona is a process, or corona is a phenomena which is produced whenever we place two conductors near to each other, having the the distance is less compared to the diameter of the conductor. At that time corona will appear, and these are the effects of corona that we already discussed. Now the first topic is critical disruptive voltage. Now this is the voltage, we can say whenever the corona is start forming, uh, whatever the potential or whatever the voltages uh, we observe or we measure, that are the critical disruptive voltage at which the corona is start forming. So these are the two conductors, means conductor A and conductor B, and uh, these are the radiuses of the conductor A is RA and the radius of the conductor B is RB. Now this center line indicates this is the separation between two conductors. Now the distance from the center to A is x and to B is d minus x. Total distance is d, that's why it is d minus x. Now RA is equal to RB, means both our radiuses are same, so that's why we can say R. And a minimum potential required uh, to start the ionization of the air at the conductor surface is called the disruptive voltage, and it is expressed in kV uh, RMS per peak to the neutral. Now value of the disruptive voltage reduces by bad weather, means as I told you in the previous slide that if the weather is containing the moisture, then it requires less voltage to form the corona, means that atmosphere supports the corona process. So such as fog, means if the atmosphere is foggy or rainy, or if there is a snow, then that atmosphere supports the formation of corona, means it requires less disruptive voltage to start forming the corona. Now as we understood this diagram, so from this diagram we can see that if the diameter is more than the spacing between the conductor, at that time corona start forming, or we can say at that disruptive voltage corona will start forming. So single phase transmission line diagram is drawn over here. So as I explained you, whatever I explained is written over here. And one more thing, D is the distance between conductors, such as D is greater than or equal to RA plus RA and RB, means it is more than the diameter of the conductor, so that's why it is mentioned over here. And plus Q and minus Q are the charges per unit length of the conductor A is plus Q, and minus Q is the for the conductor B. Now the electric field intensity, as we know that V is equal to Q by C, and we can write V is equal to EC, and C is the permittivity, so 2 pi epsilon 0, and this is the distance. So Q by D means Q by permittivity into D. So electric field intensity at point P or at distance x for the center of the conductor A, due to both the line charges will be E at x is equal to Q by 2 pi epsilon 0 x, and for the second conductor it is the distance which I explained you, that is d minus x over here. So the Q by 2 pi epsilon 0 d minus x. If you solve this to Q by 2 pi epsilon 0, we are taking it common, so that will become 1 by x plus 1 upon d minus x. This is equation number 1. Now the potential difference between two conductors, so we are taking integration of the distances. V is equal to minus ex dx, and integration the distances are both are means from minus d minus r to r. Now we are placing ex over here, so ex is q by 2 pi epsilon 0 into 1 plus 1 by x plus 1 upon d minus x into dx. Now when you take the integration of these two, place the values of 1 in below equation. This the equation 1 is replaced over here. So v is equal to q by epsilon 0 ln d by r. So this is the potential, we can say voltage, means voltage at which the corona start forming. So v is equal to q by pi epsilon 0 ln d by r, where d is the distance, r is the radius of the conductor, q is the potential, or we can say charge, epsilon 0 is the permeability of the medium. So the potential difference between the conductor, here we are just making q as a subject, so q is equal to pi epsilon 0 v divided by ln d by r. So this will be the equation number 2. Now the gradient, means from which the potential will transfer when the corona forms. So gradient at point P is given by E at x q by 2 pi epsilon 0. We are just putting the equation on over here again. So Ex is equal to q by 2 pi epsilon 0, and once you solve this bracket you will get d by x minus x into d minus x. This will be the equation number 3. Now substituting the value of q from the equation number 2 in the equation number 3, just we are putting the value of q over here. So Ex is equal to pi epsilon 0 v divided by ln into d by r into 1 upon 2 pi epsilon 0 d by x minus dx. So the common terms will be cancelled out, and you will get Ex is equal to vd voltage means disruptive voltage vt into d divided by x d minus x ln d by r. This is the equation number 4, and vd is equal to v by 2 always. So for three-phase system, Vd is equal to line voltage divided by root 3. Vd is the phase voltage or disruptive voltage for particular phase, so that's why V line divided by root 3. And from that equation it is easy to see. From that equation we can see that the gradient increases as x decreases, means as we decrease the x, the gradient will increase. So from this equation you can see that Ex is proportional to 1 over x, where x is the gradient, and the Ex is the means gradient, x is the distance and Ex is the gradient. So Ex, as we increase as Ex will increase, we can say the distance is less, and if Ex is less we can say the distance is more. So point P moved towards conductor A. From this equation we can say x is equal to r is maximum, so we can write the gradient equation G max is Ex is replaced with the Emax, so Vd into d divided by r into d minus r ln d by r. X is replaced with the r, so here Vd by ln d by r. So that's why we are taking Vd is the subject, so this will become this whole term will multiplied with the g, so r into g max ln into d by r. This is the equation number 5, and Vd indicates that it is the critical disruptive voltage at which the breakdown occurs. Breakdowns means what? At that time charges start transferring from one conductor to other conductor, means ionization will take place between two conductors. If there is a moisture in the air, then that air will get ionized and moisture will get evaporated, and charges start transferring from one conductor to other conductor. So this is the voltage at which this phenomena is started, or starting of the corona. At this voltage the potential gradient develop is equal to the breakdown strength, means as breakdown strength is more compared to the potential gradient, at that time charges transfer from one point to other point. So of the air is ionized, and which is denoted by the GO. So again G max is replaced with the GO, at which the gradient means potential gradient is created. So Vd is equal to R into GO ln d by R. But for any other temperature and pressure, the value of GO is different, so that's why GO dash is equal to delta into GO, where delta is the relative air density, means it is depending upon the weather condition. If the weather is having more moisture and if weather is dry, both having different relative air density, so that's why G O dash is multiplied with the delta, and delta is the relative air density of the particular atmosphere, and it is correction factor. So again we can say that the relative air density correction factor, which is depending on the pressure and temperature, which is given by delta is proportional to pressure and proportional to 1 upon temperature, means inversely proportional to temperature. If temperature increase, we can say the relative air density will decrease. If air having more moisture, then we can say the density of the air is more, and if there is there is a dry air, then we can say density of the air is less. So this is the standard equation that we need to remember. So delta is equal to 3.92 b divided by 273 degree Kelvin plus T. So where B is the pressure in cm of mercury, means this is the pressure, and T is the temperature in centigrade. So this is the pressure in the cubic meter, and this is the temperature in degree centigrade. This is the standard equation that we need to remember. Now just putting g is with the go, and it is multiplied with the relative air density. So again we are writing the disruptive voltage equation. Vd is equal to r into delta into go into ln d by r. This is the equation number 8, and this equation is valid for the smooth conductor. If conductor having rough surface, then this equation is not valid, and also this is valid for the solid conductor. Means the conductors are solid, and means no hollow conductors, means solid conductors. But the surface condition smooth or rough for large cables and stranded conductor. So another correction factor must be introduced in VD, because surface of the condition may be smooth or rough, or we are using stranded conductors. So surface may be maybe of the surface of the conductor may be rough or smooth, because we are using number of wires to make it stranded. So this VD is again written as, here one factor is introduced, that is MO, the factor considered for the surface condition of the wire, smooth or rough. So here the factor is the factor which is multiplied over here, that is r theta g0 m0 ln d by r. The final expression for the critical disruptive voltage becomes like this, and the unit of this VD is kV per phase, and equation number 9 indicates this is the critical disruptive voltage at which the corona start forming. Now M0 is 1 for the polished wire, means there is no roughness. If M0 0.98, we can take M0 between 0.98 to 0.93 for the rough surface, and we can take M0 0.87 to 0.80 for the stranded conductor or stranded wires. So we can you have to, students, we have to remember these values while we calculate the examples related to critical disruptive voltage. So this is how we can derive the equation of critical disruptive voltage. This is the voltage at which corona is start forming. Now the advantages of corona. So once corona forms, so corona is we can say air surrounding to the conductor becomes conducting when corona forms. That at that time the air is called at the means we can say surrounded to the conductor, the surface, from the surface of the conductor to the air at which corona appears, it is that will become conducting, and virtual diameter of the conductor will increase. Means the area in at which or in which the corona forms, that is the virtual, that will become the virtual diameter of the conductor. So if the conductor diameter is d, then due to corona that will become d plus x, means x is the additional diameter of the conductor or diameter of the corona, means uh, 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 till that periphery corona appears, so ultimate diameter of the conductor will increase. So increased diameter decrease the electrostatic stress between the conductor. So if the electrostatic stresses between conductor reduce, so that will reduce the probability of the flashover between the conductor. So there will be no flashover between the conductor due to the ionization. So as the diameter, means virtual diameter of the conductor will increase, that reduce the probability of the flashover, and it will improve the system performance, means it will reduce the stresses between conductors, so the system performance will improve. Now the third advantage of the corona is effect of transient produce. sorry effect of the transient produced by the lightning surges and other causes are reduced due to the corona, because charge induced on the we can say line by surges will be partially dissipated by the dissipated as a corona loss. Means whatever the charges induced on the at the time of surges which will be dissipated because of the corona, and so that in this way it acts as a safety valve, like suppose we are giving as an example over here pressure cooker. So if the pressure cooker reaches inside pressure of the pressure cooker will reaches extreme level, and the we can say the wall which is the CT, or which is means the air which is sorry the what we say अंदर थी अंदर से जो मतलब भाप निकलने के लिए जो जगह होती है वहाँ पे हमने जो सिटी रखा है वो अगर ऑपरेट नहीं होती है तो जो वाल होता है वो क्या हो जाता है मतलब टूट जाता है, ब्रेक हो जाता है और प्रेशर कुकर को फटने से बचा लेता है. सो दिस इज़ लाइक सेफ्टी वाल्व. वेन एवर द सच सर्जेस occur at that time, high potentials will be created and that will be discharged through the corona, discharge as a corona loss. So these are the advantages of corona. So from this we can say that corona is advantageous phenomena, but corona has certain disadvantages also. If the corona appears, the power losses of the line will increase, and that will reduce the efficiency of the transmission line. And corona currents are generally non-sinusoidal, and that produce non-sinusoidal currents will produce the non-sinusoidal voltage drop, and that produce the radio interference in the nearby communication line. So whenever the such non-sinusoidal voltage drops will occur at that time, that can harm the nearer communication line, and that can generate the harmonics into the nearer communication line. So this is the biggest disadvantage of the corona, and due to that harmonics are produced in the line. And during corona the O3 is formed, means ozone gas is formed, and that gas reacts with the material. This ozone gas can be responsible for the corrosion on the surface of the conductor. So as the corrosion due to the corrosion on the surface of the conductor, whenever the corona forms, the faint glow will be the brighter because the surface of the conductor will become rough. So these are the disadvantages of the corona. So uh, students, if you have any doubt after this presentation, feel free to call me, and you can message me, and you can WhatsApp me also. We can solve this doubt in the doubt solving session. So after this topic we have the worksheet question as well as the assignment question. The worksheet questions are what they mean by corona, and what is the relation between conductor size, conductor shape, conductor surface with the corona. And the assignment question are derive the equation of critical disruptive voltage, and the second question is define the advantages and disadvantages of the corona. The instructions related to this assignment question and worksheet questions are written below this assignment question and worksheet question. Please read it carefully. You can take the snap of this. Thank you very much. Thank you, student. Jai Swaminarayan.